We're given a cubic to factorize, except this cubic is in terms of x and y, so presumably y is also a variable. So normally I would say that f of x was this thing here, but now it would actually be f of xy. So to show that x minus 3 is a factor, let's put x equals 3 in and then use the factor theorem. You can either, or you could just say let x equal 3 into star. That's probably a little bit easier. We're going to get 27 minus 5 times 9, 45, plus 2 times 9, 18y, plus 3y squared minus 24y minus 3y squared plus 18 plus 6y. And we're going to have 3y squareds cancelling. The 6y plus 18y is going to cancel with the minus 24y. I'm going to get 27 plus 18, which is 45. So I do indeed get 0. Now to factorize it, we can do polynomial division. So x minus 3 into this entire expression star. The only thing I'd say is factorize out, like basically group the x squared terms. So actually I'm going to get 2y minus 5, lots of x squared. And then the x terms, here we go. Sorry, not that one. This one, this one, and this one. So it will be y squared minus 8y plus 6, lots of x. And I'm left with 6y minus 3y squared. Okay, x is into x cubed, go x squared, multiply back through. This is 2y x squared minus 5x squared, and I'm going to be adding 3x squared. So I'm actually going to get 2y minus 2, lots of x squared here. And bring this down. Divides to give 2y minus 2 lots of x times back through. Minus 3 lots of 2y minus 2 times x. I'm just going to do a little calculation at the side now because this is getting quite complicated. Y squared minus 8y plus 6 lots of x. Then I'm going to be adding 6y because I'm minusing minus 3 times 2y. And over here I'm going to get plus 6. It's going to become minus 6. Okay, so these are actually going to cancel and I'm left with y squared minus 2y. Of course, if you make a mistake, you should know at the end because you won't get a remainder of 0. So when I divide through by x now, I get y squared minus 2y. And then I'll get minus 3y squared plus 6y. This does indeed subtract to give 0. So this means that star is going to equal x minus 3 multiplied by x squared plus 2y minus 2x plus y squared minus 2y. And we've been asked to actually factorize it into 3 brackets. We have to determine A, B, C, and D. I'm going to talk through 2 ways to do this. First of all, a quick way. Now, if this is going to factorize, they've already kind of given us the hints. We're going to need an x here and an x here. That will get me my x squared. I also want a y squared, so I can't actually avoid adding a y here and a y here. This will additionally, at the moment, also give me a xy and another xy. So actually I've sorted out the 2y part. The bits I've not sorted out are I want a minus 2x and I want a minus 2y. All I need to do is put a -2 in. And then when I cross multiply this term, that will guarantee it. So it's not too bad just by kind of logically working your way through it. Okay, now when it says to determine A, B, C, and D, I don't think it wants us to state them because we could choose A to be, we could choose B to be -2 and D to be 0, or B to be 0 and D to be -2. So the main thing is our answer here. That's all that's actually wanted. Now, if you struggle with this a little bit, here's an alternative method. It is more complicated, but it will work in general, especially if the factorization was even more complicated. So we can take the thing that we're trying to get to and actually expand it to give x squared plus cxy plus dx. That's when I times these by, or the ones on the right by x. And then it'll be plus axy plus acy squared plus a dy. That's when I multiply ay by everything. Plus bx plus bcy plus bd. So factorize out, I've got x squared, and I've got lots of terms involving x. I've got cy plus ay plus b plus d. Lots of x. And then acy squared plus ady plus bd. Actually, I missed a plus bcy, but I think that is everything else. So what I can now do is compare this in purple with what I've just found. So it must be, if I look at the y terms, that a plus c is equal to 2. And then b plus d, that's the bit that was left alone to times by x, that must equal -2. AC, the term with y squared in, is going to equal 1. And then AD plus BC, the term in y, is going to equal -2. And actually, finally, this is also very useful. BD is actually going to equal 0. So look, it's okay, it's a lot more involved, but you can see the nice algorithmic nature of it. So because of the symmetry, it doesn't matter which one of these is 0, but one one's going to have to be. So I could, for example, let B equal 0. And that means that D will equal -2. So I've dealt with that one, and now with that one. And then what else have I got? I could rewrite this. So it's going to be oh yeah, -2a is going to equal -2. So a is going to equal 1. And that means I've dealt with that one. And that means that c is 1. Okay, because both of these are true. And we've managed to get it. So you could now piece it back together to give star equals x minus 3. And then just replace in this all of our terms. So it's x plus y plus 0. So I can ignore that one. And then x plus y minus 2. So it works out. This takes us to the second part. Factorize this expression. Now, two things. We're not given a factor this time. We're going to have to figure it out. And secondly, this is actually a cubic in y, not in x. So I'm going to be substituting in some different y values. So let y equal 1, for example. We'd get 6. Oh, I should just also say that because we're expecting this to be, it's going to factorize with integers as our final numbers. We're looking for things that are going to go into 10. So try things like 1, 2, and 5 and the negatives of them. Start off with the small numbers because they're going to be easier to figure out. So 6 minus 1 minus 21 plus 2x squared is 12x minus 8x plus x squared minus 5x plus 10. And there's no way the x squared terms are going to cancel. This is going to be equal to 0. This actually gives a little bit of a clue for what we're looking for. We want to somehow cancel out the x squared terms. And actually, I can kind of see where to go next. Let's let y equal minus 2. I think the other factors, just like in above, actually x was equal to something to do with y, but we're looking for the factor that is just a number by itself. To make these cancel, it's going to have to be minus 2. We should just check that we get 0. I'm pretty confident it's going to be true. So 6 times minus 8 is going to give minus 48, then minus 4 plus 42 plus 2x squared plus 12x plus 8x minus 2x squared, those two cancelling as we wanted. Squaring that will give 4, so minus 20x plus 10. And the 12x plus 8x cancels to minus 20x. Then this here is going to become minus 10. So these cancel. We get 0. And therefore, by factor theorem, y plus 2 is a factor. So same deal now. Let's try and do a division by y plus 2. Right, where are my y squared terms? I've got a minus 1 and I've got a minus 5x here. So I could write it as minus 1 plus 5x, lots of y squared. And then careful with the y terms. Do take this steady. So I've got this one, and this one. X squared minus 4x, and then minus 21, lots of y. And I'm left with 2x squared plus 12x plus 10. And I think I sorted that one out, didn't I? The x squared y. Yes, brilliant. Let's try this division then. So y's into 6y cubed are going to go 6y squared, multiply back through. I'm going to get minus 1 minus 12, so it's actually going to become minus 13. You know what? I'm not gonna take the minus out of the whole thing. Minus 13 minus 5x, lots of y squared. Oh, I will take it out now here. So minus 13 plus 5x times y when I divide through by y. I forgot to bring this one down. Okay, then it's going to become minus 26 plus 10x, lots of y. I'm going to be left with x squared, then I've got minus 4x minus minus. that's actually going to become x squared plus 6x. And then I've got minus 21 minus minus 26. Actually, that's going to become plus 5. Lots of y. Oh, okay. And then we're left with x squared plus 6x plus 5 here. Multiply back through, so 2x squared plus 12x, sorry, doubted myself there, plus 10. And these will cancel, we will be left with 0. So where are we up to? We've got the expression. I didn't actually call it anything. I could have called it double star maybe, but it's going to equal y plus 2 times 6y squared, this thing at the top. This is undoubtedly trickier to factorize, because last time we had an x squared and a y squared, but this time we've got a 6y squared. Could still try things out. So I think it is probably a good idea to start with, especially if you're under time pressure, because the nice thing is the x squared. So I'm going to put some amount of y in. It's either going to be 6 and 1 or 3 and 2. I'm definitely going to have a plus x and a plus x. And then I also need a 5. Um, so that's going to involve having a 1 and a 5. That's the only way that could possibly work. So I think, and oh, they're going to have to be plus or minus. That's the only thing. I've got a plus 6x. So yeah, they have to both be plus. Let's see where this gets us to. Actually, I'm going to, yeah, it's whether I put, okay, I'm going to let this be A and this be B. Because I could go with 3 and 2 or 2 and 3 or 6 and 1 or 1 and 6. So let's not worry about that bit. So if I expand this, then I'm going to get a b y squared. So I can see that AB is going to equal 6 plus a xy plus 5ay, then plus b xy plus x squared plus 5x plus by plus x plus 5. So I'm just going to roll out the bits I'm not actually interested in. I've got the 5 that I need. I've got the 6x. I've got the x squared. I've got the AB as 6. Now what else can I see? I've got A plus B. That's my AXY plus my BXY. That's going to equal minus 5. And then I've got 5. I've got the Y term. So 5A plus B is going to equal minus 13. And is that everything? I think that's enough anyway. So now I can solve these two simultaneous equations. I can subtract them, which will, if I just write it underneath. So 4a, if I subtract them, is going to equal minus 8, meaning that a is minus 2. So b will equal minus 3. Everything checks out, I think. So it's actually going to be x minus 2y plus 1 and x minus 3y plus 5 is our final answer. So nice thing about this method I just used is that I kind of used some knowledge of just seeing straight away we had to have 1 and 5. Okay, rather than calling it like E and F or whatever, I could see that I had to have an X here and an X here. So the only unknowns I introduced were A and B, and that just led to three equations of which one I could easily solve these simultaneous equations. I could have tried numbers out to see if it worked. You might be able to do it by eye, fair enough, but this is quite a safe way of doing it. When I originally did this question, just looking back, I'd actually did it a long time ago. I in fact went to the method I did here. I wrote it out as this, and it just made it so much more complicated. Um, I ended up with like hidden quadratics and things that I ended up having to solve. I still got to the solution, but so you can do it, of course, and by all means give it a go, but much better to kind of, take shortcuts where you can. Oh, good question. Well done on your efforts.